A combustion analyzer goes through a warm-up process where it's checking the different sensors, it's checking that everything's plugged in properly, and that everything is tuned up and ready to go. It is also making a reference for your oxygen sensor to 20.9%. Now, where you allow this warm-up is extremely important, because you want to let your combustion analyzer warm up in an environment where you have no carbon monoxide present and you are in fresh air. Okay. Now, pro tip: do not perform this process standing right next to your exhaust pipe minutes after you have just parked your service vehicle.
This episode brought to you by Fieldpiece. If it doesn't make a difference for the field technician, then we don't do it. Learn more at fieldpiece.com. All right, everyone. Thank you for joining us once again on Did You Know, the ESCO HVAC podcast. So today we're spending time with my good friend Tony Gonzalez from Fieldpiece. How are you, sir?
I am wonderful. Living the dream.
Yeah, I hear you got a little bit of cool weather out there in sunny Orange, California this time of the year.
Absolutely. I mean, typically people wouldn't envision this be Southern California attire with my hoodie and my little down vest here, but we are at a high today of a frigid 62 degrees, I believe. And so, this is totally warranted, the wardrobe of the day.
Absolutely. Just goes to show that, winter is here. Feels like we just went straight from a warm late summer right into winter again here in Indiana. And so when we look at the season coming upon us, there are a lot of things we can talk about to help our technicians, to help our industry and community to be more efficient with their time. As we start developing new technologies and we're making refrigerant transitions, we're spending a lot more focus on the whole better HVAC perspective of things. Like, how do we do things better, right? And so to be more efficient, I mean, it's always been the key to have the right tools. And now technology is really allowing our tools to become more advanced, to be a whole piece of that commissioning and diagnostics. And so let's talk about the ways that Fieldpiece is moving the industry forward using tools and technologies.
So that's an interesting point of using our time more efficiently. And so from a contractor's perspective, many of them would like to train their customers to so we're talking about the winter season, use the fall time to get their heating appliances checked out, tuned up, so that when they're in the middle of winter and have jobs stacked upon jobs, one of their customers don't just call up because their furnace just absolutely turned off and they are in immediate need of a service, right?
Emergency.
And so educating customers and then having the ability to have tools to perform tests like a combustion analysis to properly set and tune the heating appliance to run safely and efficiently is a very important process in the job of a contractor that will allow them to, number one, provide a additional service to their customer that a lot of other contractors just are not doing, but then also giving their customer the peace of mind that their equipment is running safely and efficiently and will not break down on them in the coldest of times.
Yeah, absolutely. We have a lot of conversations about this transitions that we're doing with technology. And there's a lot of names for it. You can call it electrification. You can call it, decarbonization. There's a whole variety of terms that we can call it, but it really comes down to just being more efficient with the energy that we're using. And if we think about gas appliances, there was a time not all that long ago in our industry where it was a matter of adjusting a shutter until the tip of your flame was just right. And you went, yeah, that looks good, right about right there. And that was not the extent of efficiency measuring and monitoring. And fast forward a couple of decades, now we have the ability to fine tune these gas appliances and get optimal efficiency out of them. So we're doing two things. We are providing that service to our customer, making sure that they're utilizing their funds, their energy allowance as efficiently as possible. And at the same time, we're actually providing that service to the environment by making sure that we're maximizing that BTU efficiency out of those fuel oils that we are still using. We're going to be relying on fuel oils for quite some time. It's a wonderful thing to think about a complete move to the heat pumps, but in some applications, it's not going to work properly for us. And we have to make sure that we're focusing on that energy management of our systems. And so, what things have been changing in the world of combustion analysis as we start moving forward with technology?
Well, there's some pretty exciting things coming about with instrumentation to perform combustion analysis. Uh, I know when I talk to contractors about what their current pain points are, with the tools that they use, uh, a lot of them share the number one, the overall cost of ownership
Yeah.
of having and maintaining a combustion analyzer, because the constantly having to swap out a sensor due to it just degrading over time. And I think what's less known is the fact that, well, in your typical combustion analyzer, you have two primary sensors, right? Well, there are many sensors, but two of them are, you have an oxygen sensor and a carbon monoxide sensor. Now, what contractor may or may not know is that by just simple exposure to the ambient air, those sensors are degrading over time, meaning that whether they are using their tool or not, their sensors are exposed to the ambient air and they are degrading, right? So typically, contractor needs to swap out a sensor every 1 or 2 years, depending on the activity of the tool. And so, for those that are familiar with Fieldpiece, we design products to help you do your job easier, faster, and better. So, in order to address that and to lower the overall cost of ownership, we've innovated this technology called Sensor Vault technology. And what Sensor Vault does is that when you turn this tool off, you might hear a click, you might not. Um, but that click, when you turn it off and it starts the a purge sequence of the analyzer, seals both the oxygen sensor and the carbon monoxide sensor from the ambient air, thus pausing the degradation of the sensor when you're not using the tool. And so because of that, we're able to provide the contractor a 4-year sensor life warranty so that their sensors are going to last them 4 years rather than the 1 or 2 years. And that when the day comes that when they do have to replace the sensor, they are completely field replaceable. There's this little door panel just right here on the bottom that pops out, and you just unplug the sensor, plug the new sensor in, and your tool is set up and calibrated because the calibration data lives on the actual sensor. And so that's just one example on how the modernization of combustion analysis um, allows the technician to not only lower the overall cost of ownership, but ensure that they are taking accurate readings on these appliances every time.
Wow, yeah, that's pretty crazy. I mean, that's definitely a new innovation into the industry. Is that something that we're going to see hitting the market? Is it already out now?
Yeah, so this is already out. The Fieldpiece combustion analyzers, there are two models. There's the Cat 85 combustion analyzer, which is the one that's in my hand, and a Cat 45 combustion analyzer. Both are designed for the residential and light commercial pieces of equipment.
All right. Fantastic. So let's walk through a quick sequence of operation, right? I'm a young technician. I've just gotten I've just been handed over my new combustion analyzer. May have had some intro training at the shop, but I'm out on the job, right? Let's walk through what I should do as a technician, starting from the van before I even head into this house.
That is perfect because when we train on combustion analysis, we start from when they park the truck on the curb right in front of the customer's house, right? Um, so yes, you arrive on a call and you take your combustion analyzer case out of your service vehicle, you pop it open, you pull it out of your bag. That is step number one. Step number two is you want to power on your combustion analyzer and let it go through its warm up process. So I'm going to start this right here. And there was another click that just unlocked the sensors so they're able to
Start reading.
sense the oxygen to take readings. So a combustion analyzer goes through a warm-up process where it's checking the different sensors, it's checking that everything's plugged in properly, and that everything is tuned up and ready to go. It is also making a reference for your oxygen sensor to 20.9%. Now, where you allow this warm up is extremely important because you want to let your combustion analyzer warm up in an environment where you have no carbon monoxide present and you are in fresh air. Okay. Now, pro tip: do not perform this process standing right next to your exhaust pipe minutes after you have just parked your service vehicle, as you might get traces of carbon monoxide during the warm-up process. But when it goes to this warm-up process, it is calibrating the oxygen sensor to ambient levels of oxygen, but it's also zeroing out the carbon monoxide sensor. So step one is proper warm-up of your combustion analyzer. Okay. Now, step two, walk into the building, right? Now, what is very important is to perform an ambient carbon monoxide test as you walk through the building. Now, I've seen some contractors that I would call uh, kind of alarming or concerning their customers. Like, hey, I'm walking through, checking sure there's no CO, making sure you guys are safe and not in danger. But there's a much more subtle way to just check for ambient CO, and you can use a combustion analyzer to help you do that. Now, on the Fieldpiece combustion analyzer, this is your typical combustion screen where you see a bunch of measurements. But you can enter back to the job menu, and whether you see it or not, there's another button that says ambient CO. So I'm going to
Yeah.
press on that ambient CO, and now you just get carbon monoxide on your screen. And you can very casually, without alerting your customer anything, just walk through the building, heading towards the appliance under test, and just have these in your hand and just monitor what the CO levels are, right? If you stay at zero or just get a tick one or two, there really isn't much to be concerned about. However, if you're walking through a home and you're getting into the teens, 20s, and 30s, then that's something you're probably gonna want to stop what you're doing and look to investigate. And if it's high enough, right, you're gonna want to, open up some windows, open up some doors, and start ventilating the area. But step number two, you can perform this test as you're walking towards the appliance under test. Okay. So that's something that you can do. You can save the results of that test by pressing the save button, and all this can be included in your combustion report at the end of the job. Now I'm going to go back to the job menu,
Mhm.
and now I am at the appliance under test.
Okay.
Okay, so
Fuel's out, ready to roll.
feels out ready to roll. However, there is one thing we should consider, and that is what is primary air, right? So, primary air is the air that is being fed to support the combustion process, right? Combustion, we need oxygen, we need fuel, and we need heat. Now, on a combustion analyzer, primary air is part of the combustion efficiency calculation that the tool performs. So, on the Fieldpiece combustion analyzer, during that warm-up process outside, it is saving the ambient temperature outside as your primary air. Okay. So if you had a 90% furnace where you're pulling in outside air to support the combustion process, there really is no need to update what that temperature is. However, if you're not pulling in outside air and there is a dramatic difference, let's say 15, 20 or so degrees from inside or from outside to where the heating appliance is, you might want to consider updating that value to get the most accurate calculations.
Sure, I get.
And so with this tool, you can just go to this button that says primary air, and now you're in the primary air screen and you are standing by the appliance. You can save that in there. And now you've updated the primary air that's saved to support a more accurate combustion analysis calculation. Okay. Not a lot of people think about that, but it's something to help ensure that you get the most accurate measurements and calculations. All
Yeah,
right.
absolutely.
Yeah.
Especially if I'm not doing a true two-pipe system. I've just got a single pipe and I'm using the actual, ambient air for the combustion source for my burns, which think about our older furnaces, especially our 80 percenters. That's what they were doing. They were using internal draft. Hopefully, we've gotten to the point where we're installing all of our high efficiency appliances with our two-pipe system, bringing in that nice, condensed oxygen rich air from outside. But If not, now we have the ability to make sure that we're zeroing into the atmosphere where we're bringing that air from.
Absolutely. Okay. So now we're ready to start taking some measurements, but the first thing we want to do is ensure that the combustion analyzer knows the fuel type and the equipment type that you are working on. Yeah. So typically there's a button somewhere here on the CAT 85. It's right under these big measurements right there. So I'm going to tap on that. And now you just have a bunch of different options for your fuel here. And we're just going to keep it on natural gas. Now, once you select the fuel type, now you pick the equipment type. Okay. So atmospheric is about a 70% natural draft, right? Power burner is about an 80%, and high efficiency is 90% or above. So I'm just going to go ahead and click or press on the high efficiency. And now the combustion analyzer is set to high efficiency. Now, another reason why that's important, because if you see on the left side of the screen here, you see these ranges. Now, on the screen, starting from top to bottom, the combustion analyzer is displaying your stack temperature here, your oxygen percentage here, your carbon monoxide, and your carbon monoxide air free. Towards the bottom, you have other calculations that you might not use on a daily basis, but just so you know what they are, like excess air, dew point, combustion analysis. And actually, interesting enough, on this version of the combustion analyzer, you also are viewing your draft pressure at the same time. But we'll get to that, okay? Now, the reason I bring this up is because here along the left, you'll see you have these min-max ranges.
Right.
Okay. And so for those of you that are familiar with the National Comfort Institute, they provide certification courses for combustion analysis and carbon monoxide safety. And in those courses, they have recommended ranges of stack temp, oxygen, CO based on the equipment type so that you have an idea of is the number that you're measuring a
Is it-
good number
Yeah.
or not?
Exactly.
And so a lot of those tables are built into the Fieldpiece combustion analyzers, and that's what these ranges are.
Sure.
And so when you're sampling the exhaust gases, if you have a yellow value like you see here, then that's an indication that that measurement is slightly or just out of range of what would be typical of that piece of equipment. And if it's white, that means you're within the acceptable range, right? And so obviously, by default, we are going to want to refer to what the manufacturer design specifications are for that piece of equipment. But in the case where that's just not easily accessible or we just don't have access to it, having these ranges are also helpful to be able to understand if I'm in the ballpark with this piece of equipment.
Yeah, I mean, think about the technician that, might not have been in class for a year or two. They've already went through a season of not using it. They're getting the tool out again going,
Yeah, absolutely. Okay. So now that we're set up and we're ready to begin sampling measurement gases, the location of where we sample the combustion gases is very important. Okay. So let's just stick with this high efficiency system. And generally, you want to install a test port at least 12 to 18 inches above the inducer fan, right? So you want to make sure that you're not too close to the box, but that you give the combustion gases time to settle and get to a steady state in the flue.
you bet.
Okay. So then you insert this into your flue, and your combustion analyzer is now sampling the combustion gases. Now, as we know, in the flue of a high efficiency furnace, we have the presence of water, right? That's just how those appliances work. That's what makes them more efficient than other appliances.
Yeah.
And as you know, or maybe you don't know, these sensors within a combustion analyzer are not very fond of getting wet, right? They don't want the moisture, they don't want the water vapor, they don't want none of that. So your typical combustion analyzer is going to have something like a water trap, right? Somewhere between where you're sampling the gas and the sensors of your tool.
Absolutely.
Now, the purpose of that water trap is to uh, take the water vapor, condense it, and then just hold it for you so that it does not pass through to the sensors. Okay. Now, you have to remember to maintain that water trap, right? You're going to have to remember to open it, pour it out. What you don't want to do is leave a filled water trap in your truck overnight, have it freeze, have it crack your trap, and now you have a warranty process, right? again, how do we make the job easier, faster, and better? Well, if you notice on the Cat 85, there is no water trap
Sure.
in between the handle and the meter. And it's not because we developed sensors that are impervious to water or moisture, it's that we've innovated with another patent technology that we call hydrocycle pump. Now, what hydrocycle pump does, you gotta love these marketing words, right? Sensor vault, hydrocycle pump. Um, you as you insert your probe into the flue, you are sampling, right? There's a pump in here that
Mhm.
is pulling exhaust combustion gases and the water vapor into your probe. And in this handle, there's a mini condenser. And what this condenser does is that it condenses the water vapor here. And instead of storing it for you, there's a secondary pump that is just pumping it back out into the flue from where it came. So it's just cycling through here, and there's no need to have a water trap anywhere else downstream, and there's nothing to maintain. So the hydrocycle pump um, just takes away one thing that we have to consider to maintain the combustion analyzer.
Absolutely. How far into our flue gas stream are we going to be inserting our test probe?
So I would say it varies slightly on the size of
Of the
of
pipe.
the flue,
Sure.
but for your typical high efficiency flue pipe, they're not very big. They're maybe a couple of inches. So generally, you should be fine just positioning the end of your probe in the middle
Okay.
of the
Of the pipe.
of the of the flue pipe,
Yep.
right? If you're on another appliance where you have a much a larger width stack or flue, maybe 4 to 6 inches, you would want to generally position it where you get the highest stack temp and the highest CO reading. But generally, if you're in the middle, you should probably be okay.
Okay. It's good to know.
Yeah.
Fantastic.
Okay, so now we're back on the job site and we are in our test port and we're sampling gases. We don't have to worry about water. Hooray, Fieldpiece.
Hey.
Now we can focus on what the measurements are actually telling us, right? And so, for diagnostic purposes, the main measurements you want to look at are your stack temperature, your oxygen percentage, and your carbon monoxide that is being generated in the flue, right? And so for a high efficiency furnace, you can expect a lower stack temperature, somewhere in the range of 100 to 130 degrees is kind of what you're looking for there. As far as your oxygen, you're looking somewhere between 6 and 9% is going to be the sweet spot. And for your carbon monoxide generation, what what NCI teaches is that you for sure want to be under 100, 99 or below in the flue. However, under 50 would be even better than that. But generally, those are the ranges that you're looking for just to ensure that you're getting as close to complete combustion as you can, right? In the real world, we're not looking for complete combustion because that's not possible. But we're looking for the most complete and finding the right mixture of air and fuel and heat to get almost complete combustion.
Fantastic. Tony Gonzalez of Fieldpiece, how can we learn more about combustion analyzer training and other training opportunities brought to the industry by Fieldpiece?
Well, you can start at two places. One, you can go to fieldpiece.com, which is our main website, and learn all about the Cat 85 and the Cat 45. However, as a supplement to this training,
Hmm?
we have our online learning resource, Fieldpiece University. And it just so happens that we have a great training track on combustion analysis, starting from taking your tool out of the truck all the way to creating your report at the end of the job. It's a great training track for you to reinforce, some of the best practices that you learned at one point and maybe have forgotten over the years. And those are the two locations where you can learn more about not only the Fieldpiece product, but the application of combustion analysis.
Fantastic. Well, we sure appreciate that, my friend. I look forward to more trainings and more technology coming out from Fieldpiece. Really look forward to seeing you at AHR and the National HVACR Education Conference. Encourage everyone to join us, and you have a wonderful rest of your day, sir.
Thank you very much. You too, Clifton.